Alright, if my audio is not coming through, I am going to like slime myself out, but here goes. So this is the beltivator. This is gonna be like the most basic possible simple beltivator I could think of because once you know that, you can kind of start extrapolating like the little things where you can make this packaging better, whatever. Yeah, so origin cube, useful for variables. I don't actually have it here. In a real beltivator, you have 3 stages. You want each one in a separate assembly, and so you want an origin cube in each one of those, and you want to mate those together. Standard origin cube stuff, but right now I don't actually care, and I don't want it in my face, so I'm just gonna get rid of it. Like this is just at none right now. And what I'm doing right now is I'm showing you how I got this. So this is a variable that defines the distance between the pitch of your belt, which is going to be like that, and the outer diameter of your belt. So what you're going to do is you're going to make 2 circles, draw a line, make a belt using those circles, and then find the distance. And that's going to be about this. Honestly, just 0.046 is fine, but I just like to be precise. If you can't memorize the value, it's way faster just do that instead of go open a different Onshape doc and like suffer. But yeah. Alright, first thing. So this entire thing is, the entire rigging is mirrored. So it is the exact same on either side. I prefer my right hand side, and yeah. This is right. I'm correct. Right. So good heavens. I prefer my right hand side, so I'm just gonna do it like that. So here you have your gear. This is going to be mirrored on the other side, so that's just going to reverse the direction. Since this is mirrored, when you're pulling on this side, this is going to rotate like that, and this is going to rotate like that when you're pulling down here. So, like this is going to loop into there, and this is going to loop into there. Of course, you're not actually spooling up the belt, it's going to be fed back up here, but this is just a convenient way to reverse that. And then on top of this, you're going to have 10/20. This is representing an 8/20, but that's pitch shifted to a 10-tooth pitch circle. Alright, so here, what I like to do, crack an X60, if you have 2 of them, and you have a Foxhorn reduction with a 24-tooth pulley, that's going to work for basically every beltivator ever. If your end effector is pretty light, I would go 4-to-1. That just means like not pitch shifting one of these or making this smaller. Right, so you're gonna stay non-construction, you're gonna be construction, and you're gonna be the outer diameter of, yeah, I need this. Yeah, so this is just, the solid circles are just gonna be my, whatever they're called, the gears, the pitch circles. Right, so the reason I specified earlier that this should be 24 tooth and 5-to-1 is because it does matter. At 24 tooth, you're moving 24 teeth in a revolution, which is like 5 times 24 millimeters. I don't know. But if you're like 20 tooth, you're moving much slower because or not much slower, but like 80% as fast because you're only moving 20 with each revolution, which does change things. So that's just you're adding on this ratio. So I mean, yeah, pretty much. You're just changing linear speed. If this is 20, I would want a less aggressive reduction, but you want this to be as large as possible, right? Because that means you get more teeth engaged, which means you can transmit more force. 24 is fine. Like 24 is the best you're gonna get most of the time, and I am not at all like sad about that. Typically I just do gearbox in the same place I do the belt, so I'm just gonna continue here and move on. Right, so here this is gonna be where we start a belt. These are gonna be equal because I want the belt to be straight in the center, right? So this has that effect, and the belt is 0.15 inches wide. And this works as an approximation. I don't know if it's the precise value, but it doesn't matter, it's fine. We're using the West Coast Products Idler. I do not remember exactly what it's called, but you should be able to figure that out. It's a round one. So that's the outer diameter of that. And this is going to be the belt wrapping around that idler. This is riveting stuff now. I will explain why this can be straight while this may or may not be. Like, it's like some of these belt runs have to be vertical, but others can be like sort of whatever. Like, doesn't matter. I will explain that in a moment if you cannot figure that out on your own, which you should not be expected to do at all. Right, so I'm just adding in the idlers I know I'm going to need. This is not constraining the position perfectly. You can constrain position as you go along. I am just doing this right now like that. It's going to be the same sort of idler here. And I think I'm just going to make this, like constrain this right now. I have my line width smaller and my construction lines are modified because I went to this menu here and I went to like this, but it doesn't matter. Like, this is just gonna make like the weird stuff that happened where I couldn't select this line. That does cause that when the line width is smaller, but I like it because it's clearer. If I have a super complicated sketch, I'm not trying to like sort through different lines individually. At least I want to be able to see what's going on, and so it's worth it because of that. So the bearing block goes like 7/8 of an inch into the tube, and so having just 1/8 of an inch of clearance is fine. That's great. Yeah, and this is gonna keep happening like the same way pretty much. You have your idler, you space it off like that. Tangent. Tangent. Yeah, okay. I'm just gonna check these are 0.15 away. Okay. And if you're constraining everything like tangent and parallel and stuff, it all kind of shakes out to be 0.15 in the end, so it doesn't, you don't need to redimension that or make like equal lines or something like that. This just works, and it works pretty well. Right, so for your idler stack up, quick note, you're always gonna have like a 0.25 inch like bolt shoulder, because you're gonna have like 2 inches of tube, and then on either side you're gonna have a plate and you're gonna have a plate. So the plate down here is going to be your gearbox plates. Here it's going to be your hard stop on the first stage, and here it's going to be your hard stop on the second, or on the base stage, not the second. So you're gonna those are going to be your like 1/4 inch thick plates. Up here is going to be the gusset that ties like here and like here. So yeah, that's the thing to note. I highly recommend checking out Andrew's Beltivator because it's just such a good reference. Even I like use it just like randomly. I'm like, huh, how does this work again? And I don't want to think about it because that's like a known good quantity. Or whatever. Okay, and this is just gonna be the same because it is actually between two tubes. It doesn't look like it's between two tubes from here, but if you look down here, it does kind of go down. So, and the runs you care about being straight are gonna be this one and that one. This one, the one I'm doing right now, and the one that's between every run that's between stages, basically. I don't know. Let me explain that in a second. I'm just gonna constrain the entire belt path, and then I can explain why. So this is gonna be real quick. Just gonna. I'm gonna wrap this up down here because I want to know where the inside of my belt is. Generally, it's always the same place, but it's good practice. Like, generally the same side is always gonna be the same. You know what? This is not something I'm gonna try to salvage. I think I've mixed up my words enough here. Okay, so first use of the OD to pitch variable. Yay. This is going to be the outer diameter of your belt, inner diameter, and this is going to be the actual pitch of your belt. And here, I mean, you're just going to continue as normal. And when you're doing complicated belt paths like this is genuinely like the entire process. It's not very, like, there's not a whole lot of hype moments to it. I forget how I do this normally. Right. Dear God. Onshift is gonna take 1,000,000 years to load this. I hope not, but yeah. So You see what I mean by like the whole reference to other belt elevator thing? Because even I forgot. Because I am brain rotted by doing a 2x2 elevator, but this is not a thing I needed to do. Oh, yeah, they did that. Okay, so this is actually not gonna happen like that. Real quick, I should probably make the distinction. We here are doing a one, like, a single belt. So it's gonna go all the way around on this side, and it's gonna come around here, and it's gonna go all the way around and do the exact same thing on the other side. You can do two belts, like one on this side, one on this side. There's not really a benefit, like I see. And that means you have to you have to have a tensioner here and another tensioner probably over here, because that just makes things like more optimal. And for just because you want tension both sides for like clocking in or whatever. In this case, where you just have one, it doesn't matter, right? Everything is fine and happy with just one tensioner here, one tensioner here. So it's simpler, it's less parts, it's less belts. You don't have to cut as many. You just have to tie one down instead of two different ones, and you get, I think, generally like have a nicer time packaging things, in my opinion, but that's more opinion. Right, so this is going to be OD2 pitch. And what we're doing here, the reason we're having this idler and we can't just go all the way up like that, is because this is like, this needs wrap. So you want to have like at least 180 degrees of wrap here, because you're carrying heavy stuff, right? Like you're carrying a full elevator on one belt. And that does take some amount of wrap that you will want to have. Yeah, I'm so eloquent, right, guys? Right. And now we're just continuing the belt as normal. We're gonna have an idler here. It's gonna loop here. Tangent, tangent, tangent. Nope. Tangent. Tangent. Also, this isn't my Catathlon belt elevator. It's just easier to show like this because I have no idea what my Catathlon teammates are doing, but what are they on about? I mean, I do know, but it's like I'm flying out in how many days? Like 12-ish hours. I'm like leaving house, so I can't really follow up and like actually do good work on that. And this is just gonna be way easier to explain than, because I don't have enough thoughts in my head to like do both. Alright, and this is gonna be going up to, I'm gonna just fix this in place. Don't keep fixes in place for a long time. Like you don't want to just have them there permanently. But they are very, very useful for when you're not trying to constrain something that keeps moving around. Right. Here you can just do like a static 3D print. That's probably like fine. I think that's just what I'm gonna do. You can make it also an idler, but also like when you're readjusting things, it doesn't matter. Like you don't need a bearing there because you're doing that one time, like maybe 5, and that would be pushing it. Like you're readjusting your tension. Even if you did it every single match, you'd be doing it, let's call it like 200 times tops, and that's just not the sort of wear that matters on this part. So you can just make that like a 3D print. You want these idlers because there's a lot of friction. The elevator relies on having that. This is gonna be an inch in diameter because where are you going? Because it's, and to think here I was shilling for the fix mate. Oh no, it's just everything is fucked already. What? Oh, you are in tangent. That's the source of all my problems. Wow. Pardon my French, by the way. Alright, we're fixing you back in place. You are going to be horizontal to you. And you're going to be horizontal to you. Honestly, I don't actually care that this is like a specific diameter. But it is a diameter. Yeah, okay. I'm just going to make this vertical because that just constrains this diameter for me, and it makes my life nice and easy and simple. And then I'm going to constrain this to be like, just tangent. Because we do generally put a pocket up here, so we can just pull the belt through all the way up, and then we can feed it back down for assembly. Rather than having to like squeeze it in there and like let it loop around, it's just way easier to do it like this. Okay, the motor has been unconstrained for so long, I feel so bad. Okay, and here I'm just gonna make this construction because it does not matter right now. Okay, so you, I want to be like, I don't want to interfere with the stage. I'm just gonna make an 1/8 of an inch. That'll work fine. You can go as low as like 0.005 and still be comfortable. And here I want like 180 degrees of wrap. I think, why are you doing this to me? Can I not edit you? Like your lap. I feel like you're coincident to the circle. Yeah, you are. Okay. I am, like, I could probably like optimize this, but honestly, I'm just gonna make this 180 degrees because we ball. Also, okay, I can make this far better wrap, like easy. I say as I screw everything up and everyone hates me. Oh my god. I'm happy with that, I guess. No, that either's gonna interfere with the gear now. Alright, referencing the elevator again. How'd they do that? Oh. Oh. That's kind of swag. You with the pockets up here. I mean, I guess, bro. Yeah, I mean, I guess. Okay. So, this is gonna be your spacer. Oh god. That's gonna make this sketch complicated. This is how I normally do it. I don't know why I'm surprised. So, this is gonna be 0.5 because it's like spacer plus clearance, and this is gonna be clearance to the outside of this. Yeah. Oh, why is it doing that? Oh, okay. Yeah, that's why the pockets are necessary. And then I'm going to get rid of this guy for now. He will be back. This is the bolt circle, the Kraken. And so basically what they did here is they put the idler on the bolt circle, which adds a, like, it's just a nice tapped hole that already exists that you never need to worry about like actually having, and that works. Yeah. Oh, I'm gonna need pockets, but it's fine. You need pockets on the side, the stage tube. If you make this a plate, which you can, like you can make this a plate, it does not matter. This doesn't have anything on it, it's just gonna have these pockets here. If you make this a plate, it's probably gonna be more convenient to machine like these pockets, but it does, like, it's like whatever. If you're making a beltivator like this anyways, you're already doing plenty of plate machining, so, or tube machining through Fabworks or someone else, so just may as well get it all done. I'm just gonna make this vertical because I don't actually, like, there's no reason for it to be anything. It has no dreams, no future. It doesn't need to be vertical though. I need to clarify that. This could be as far horizontal as long as it doesn't hit the tube. And this, I'm also just gonna make it like an inch away. I think this is a lot more arbitrary because, are you not equal here? You are not, and we're constrained. Oh, holy voice crack. So this is just gonna be a gusset. So I think this is gonna be like 0.5. Oh wait, no, I remember. I like put this up here. I put the pocket in the tube, and it, like, yeah, okay. I don't know, like an 1/8 of an inch. Why don't I just make you tangent, honestly? Yeah, that works. Okay, so we just have a pocket like here, and then maybe a pocket like down here for access, and like, yeah. And this is just gonna be on the gusset, and that's gonna be your spacer. Like, you have the plate stack up, like gusset, and big tube versus like hard stop. Yeah, so I don't actually care where my tensioner goes here. Generally, you'll have some indication, but it doesn't actually matter like where you want it to be. If it's not like anywhere in particular, I just like put it, I like low down the carriage or like up here, because if it's up here, I don't know, it just sketches me out. I feel like it's gonna like tilt the carriage or something. this is all heuristics, but or not even heuristics. It's just like vibes. I don't know if that actually is a thing. But I just prefer to put it like down the center here. Prefer meaning like if I have no idea what else to do with it, I'll do that. Right. So you're gonna have your tension here, and what's gonna happen? You have your inside of the belt, inside, 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 all the way down here. So this is your inside of the belt, right? This is the outside of the belt, which means you want your inside to be contacting this, which means it needs to like do this little wibbly wobbly around somehow. Oh, I forget actually how I do this normally. I remember entirely. I don't know. I'm lying. Okay. I like to make this radius pretty generous. Like, I mean, it doesn't matter because this little part does not actually see any like load. Well, no, it sees load from the belt, but the belt isn't moving, so it's not like a dynamic load where like you need to pay attention to like minimum diameters and minimum like bend radii. No, this is just like a tensioner. Although here I'm doing a pretty good job like of obeying all that. This never matters. Like you can put this center point like down here and have this be like an eighth of a radius, and so long as it isn't like a sharp point, you're fine. And that's actually just the entire belt path. Wow. Yay me. Okay, so you can mirror this if you want. Something I do is just if you close this off, you can extrude it as your belt. Yeah, I don't know. Alright, so this should not be a construction. This should be a construction circle just for consistency. Yay. What are we doing now? Okay, so now you do hard stops and extension, and then you're done. Because this is honestly after the belt path. I mean, what else is there? So long as you're just consistent. The only thing I'll say is like these bearing blocks are little chuds. They're actually fuckers. Holy hell! Like genuinely. You need to make sure that they can roll. And that is an annoying interference to check, let me tell you. Also, don't do this custom bearing block thing. Like, I don't know why this is the only part of Angel's elevator that I don't like. I mean, I guess like you have this extra space, but you don't have it here, and it works every other time. Like every other belt elevator just has a 0.25 and it works. Why you would do this? I mean, is it theoretically optimal? Maybe, but I don't like it. It just sketches me out. Like, what are we doing? This isn't actually colliding, by the way. It would be up here, but like, it just makes me feel uncomfortable. Anyways, that's enough from me about that part. I mean, this can be 0.5. Is basically what they're saying there. So, I was showing you something. Oh yeah, these, like, you have to make shit really thin and make sure like this can slide, because otherwise you're going to hate yourself. Citation, I've done so numerous times. As in, like, hated myself. Because of this specific issue. Okay, so now we're doing hard stops. This is, wait, no, we're not doing hard stops. We're not doing hard stops. We are doing the extended position of the belt and of your whole little setup here. So you're gonna, yeah, I'm so eloquent. I want 6 inches of stage overlap. It's representing the bottom of this. So there's actually going to be a bearing block here and a bearing block here. So this only needs to be 4 inches, and then the bearing blocks will make up the rest for the 6 inches of overlap. I think that's how that works. If it doesn't, like, generally I don't care. Like, this is an example, bro. I mean, I do care, but not enough. Right, so your extended position is just going to look like that, and you're going to have your little And then, I mean, you just put this up there, I guess. This is riveting, by the way, guys, right? Whoever's watching this. Honestly, I hope that's just a shot, bro. I couldn't take it. Right, so this is all you need to do for your extended position, because that's all you need to do to check anything ever. Wait, no, I lied, but, you know, I'll get to that when we get to it. So now what I'm going to do here is your idler. No, you're not going to do idler positions. You're going to do... This is all just going to be stuff on the base stage that... is it probably good practice to just do it all in one sketch, because then you don't have to do the use thing? Yeah, but I'm not trying to do all that. Like, I'm down to delete like 10 billion uses and just have the other sketch, because it's just nicer to do it like this. Right, and then here, this is gonna change in length. Oh, actually, let me explain real quick. I'm gonna keep stalling, actually, and not explain ever why that some of these paths can be straight. Right, so I'm just gonna do everything on this side because we already have rigging here, so I'm just gonna do my other rigging here, which is gonna be representing extended. And that means that this is terrible and horrible and I don't like it now. You know, whatever, I'm just gonna mirror it. You don't need to have the extra tube like on the side anymore, like at all. There's no reason for it to be there, but except for me being lazy. Okay, so this is just, you know how you do like, for master sketch you have like a triangle? So you can make something else equal to like, or like in the same position, but like in a different like pivot position or whatever. It's like that. You have these triangles. So this is gonna be the idler down here, just up here, and on the other side. And then you're gonna do your entire belt path again. And do you need to do this if you're confident? Nah, not at all. But I like doing it. It's not generally too like long. I don't know. I mean, it kind of depends. Sometimes I won't. But you get the idea, right? You're just doing all this, especially for like the first time. Like, I mean, actually, you know what? I'm ambivalent on whether you do all that, but you get the idea, right? Like, you do these triangles, you put them up on the top, and then you have your entire extended belt path. It's nice for cutting out your extended belt path later on. I'm not gonna finish that here because I don't actually care that much. Right. How do I do hard stops? So what I do is I take a line and I slap in the middle here, right? And this is where you're gonna like do your hard stop point, right? So if you have flat hard stops, this is gonna be the flat part. But if you have like tilted hard stops, it's still gonna be like this, but like it might like be in relation to the line, right? Like one side is hooking into here, and the other side is hooking up into here. But no matter what, you still have this like line where your hard stops are meeting somewhere. And what I like to do is I just make this like in the center of this, like that. Yeah, so this is where I'm hard stopping. And I can just kind of use that like now because I can just reference this line, this hard stop line, which I'm gonna keep solid because it's not enclosing anything or whatever. So when I'm doing this upper hard stop, I can reference here, and when I'm doing the lower hard stop, I can use this and like, I mean, I guess that if you really want like to be fancy, you can make a construction line here and like put it down here and have your extra hard stop like so you can reference it directly. I personally could not care in the slightest. Also, the reason you have it halfway, part of the reason is because that lets you make these duplicate parts, right? This can be the same part as this because the distance between the idler hole and the idler hole and this is the exact same, and so you can just take like your little hard stop guy here and you can just rotate him to like that, and they can be identical parts. Of course the line here would be like down here, but you know, Right. Other than hard stops. This is how you do the hard stops. You could just have the extended position up here. I don't. Generally, like you don't even need to do the extended part at all, other than this. Um, it can be nice. Right from here, I mean, depends who you're block heading for. If you're block heading, you're gonna want to have like, if you're blocking and catting for someone who you know, like they know what they're doing, right? They are not gonna struggle to make a belt evader, like i.e. like me, who has done like at least 5 at this point. You can just take like, in your block CAD, you can just kind of. They have the belt path. They know what the belt path looks like, and they know like at least you can hopefully they can assume that you're competent and you can like do the belt evader sketch reasonably well. The first time you're gonna fuck something up, like I imagine at least. I fucked something up at least like the first 3 times in my sketch. I still do sometimes, but and this is just gonna be for the tubes. By the way, for the block CAD, and that's fine. Like, no one's gonna like defenestrate you for that. I think, unless David secretly has anger issues. But what was I on about? Oh yeah, so generally when you have like a competent person that like knows what they're doing, they know their way around the belt evader. Doing all the like clearances for a belt evader, like the bearing blocks and catting them out. I mean, it's not that terrible to do, but it is pretty terrible to do. So you should probably just give them like this. This is all you need. This in the sketches, so that they know where like the hard stop line is and what kind of the belt path looks like, and where the idlers are. This is everything you'll ever need to give them. And you can get more complicated, right? You can extrude, you can mirror this belt like in an actual like non-construction way, and have that be like a thingamabob. What's it called? You can have that as like part of your block. I don't really. I mean, it can be useful to have that because then you can like reference it when doing your pockets. So that would be something I'd do as well. And then maybe like I guess you could do your plates if you're not confident that this is like not gonna collide with anything. I would generally think though, if you're doing an elevator, in the vast majority of any case, you're always gonna have like plenty of space so that you don't need to full detail the elevator. And generally, since most elevators are gonna go like this, you can give them just this, right? And that's gonna be enough for you to say, all right, this is gonna be where the elevator is. You can reference these. I mean, give them the belt as well. It'd just be nice for them. You can reference these, whatever. CAD your belt elevator, and it's gonna be the same every time. So you don't have to do too much work with like block CADing it fully. And that's I think something that a lot of people miss with the block CAD is you don't need to be CADing these individual plates unless one you're like you think you want to reference them later, and that's going to make the block CAD or whoever's CADing off the block CAD, it's going to make their life easier. That sure, CAD that fully. Or 2, if this is like going into like some whirring mess of machinery, or like this down here, right? Then you might want to block CAD that out, right? Like you might want to have these crackings here. You might want to have like gearbox plates, but other than that, like this is fine. You don't need to be detailed with your block CAD if there is no detail to like speak of that isn't implied, right? Here, when I sketched all this out, all the details implied. I don't need to check like that these plates like don't collide with anything because I'm assuming this is like a reasonable robot that doesn't have too much stuff nearby. If there is stuff nearby, of course, CAD it fully, but otherwise, like you don't need to spend hours of time on your block CAD. You can spend like 15 minutes on some mechanisms or less and still have it come out fine because the block CAD is just there so that they have something, like people have something physical to give them clearance and to make sure that they have something like reference. You don't need the block CAD to look exactly like the real CAD is going to. You don't need the gears. You don't need whatever. You just need it to like be like a space claim, and this is kind of like what it's gonna look like. And that being said, just like for a quick note, you kind of got your belt elevators like hanging like from cracking out. Just generally, like that's normal. That's totally like a thing that happens most of the time. I mean, unless you're using like Kraken X44s, in which case you can do some weird packaging stuff to prevent it. There's no reason to actually like not do this. It's fine. You can make a cutout in the belly pan. That is so common. It's like almost every other like beltivator bot probably did like a cutout in the belly pan for these like little components here, and it worked out fine for them. And there's a bunch of other stuff you can do here where you can make like a case, you can like enclose it so it's sealed, you know. But other than that, I mean, it's pretty simple. It's not particularly like nothing crazy going on. Yeah.